joining.
Sure. So, a very good morning to all of you. A little bit of on housekeeping to begin with. All attendees are kept on mute and are requested to keep on mute. If you have any queries, please enter it in the chat box. I hope the chat box is working. Otherwise, what we will do is after the session is over and during the Q&A session, we will open it all for the mics will be open for all mics and videos, and everyone can ask their question as well. And if you are experiencing any sort of technical glitch, then please try to try to exit and rejoin the webinar. Hopefully that will work. So now coming to today's topic. Today's topic is on recovery of rare earth elements from secondary resources, which is going to be delivered, presented by Dr. Nawashad Haque. Uh, Before that, a little bit on who are Data Code. So Data Code is basically a leading organization in the field of geoscience industries, bringing cutting edge technologies and services to the industry, specifically to the growing Indian market for more than over 25 years now. And we have global partners and international clients, and we believe in the mantra of 3 E's, which is empowerment of end users, enhancement of employee skill sets, and equity to all stakeholders. Now coming to the partner in progress theme, which we have started last month, we had our first presentation from Dr. V. Balaram sir, through which we started this partner in progress theme. The objective behind this theme is to share knowledge with the community for better reach of the subjects. We want to bring eminent speakers here. It's an online and free session open to all, and we are trying to make it happen at least once in every month, preferring it to be Saturday so that people can join and because of the weekends. Who should attend? All personnel, students or professionals from the industry are welcome and can attend it and can gain knowledge from here. The main goals for this PIP is basically to empower students and professionals from the industry and create a wealth of knowledge for the society at large. Now coming to today's topic and our today's speaker, Dr. Nawashad Haque, who has joined CSIRO Energy maybe I think in 2018, and he is a currently team leader and senior scientist there in CSIRO Energy in Australia. His current research focuses on the processes, project, and technology evolution, applying life cycle assessment, methodology, and techno-economic capabilities using various tools and softwares and databases. I'll not go much into his detail because I'm sure Nawashad sir is also going to explain what is the better person to explain how the research and the work he has done and he has gone through, which he will be definitely sharing with us today. So nothing much but to add on that he contributed to develop a number of novel technologies and flow sheets for mine to metal production in CSIRO, and his publications and industry reports are widely used internally and externally to assist in various decision makings. And Dr. Haque has completed his doctorate with Department of Chemical Energy at the University of Sydney on process modeling, simulation, and optimization. So without a further delay, I would welcome Dr. Nawashad Haque to take the stage and enlighten us with his knowledge on today's topic. Over to you, sir.
Thanks a lot, Dhruvo. Can you hear me well?
Yes, sir.
Yes, sir. Loud and clear.
Yes.
Thank you. Thanks. Thank you. So I'm going to share my screen. Just a moment, and we should start from there. Can you see my screen?
Not yet.
Coming, okay?
No, not yet. Yes.
So thank you once again for introducing me and giving me the opportunity to speak to you. And I'm speaking from Melbourne, outside pretty nice weather, sunny weather after a while here. It's our winter month, so essentially that after a while we got a bit of, I guess, the sun. So although the temperature is still probably maximum temperature is 16 degree, it's quite cold compared to Indian standards. So, but I usually go to bike ride around this time, and Melbourne has got a lot of nice bike paths. I think the other colleague was mentioning where I'm speaking from, and actually we are under lockdown because in Australia, COVID situation was better over the years, and although we had ups and downs, I think this is our 6th lockdown. We had 1 week and then extended for another week, unfortunately. So it's a volatile situation everywhere, I understand. And hope wherever you are, keeping you safe. And yeah, let's discuss about today's topic. So I'm going to talk about recovery of rare earth elements from secondary resources, although I will be talking a little bit about primary resources too, and why probably important. I don't think I can go too much detail of each of these ones, but I can give you a bit of flavor what's happening in Australia, around this part of the world, in terms of the technology, in terms of the activities, and although I'll be using the slides, but I'll be speaking. So just let's start. In fact, the top photos, you can see that one. I am sort of, because of COVID now, we cannot travel. It's restricting us traveling, but I used to travel, and probably I was in India quite a while ago, but I used to travel frequently to India. We have got a lot of friends in Indian subcontinent, Indian School of Mines, National Metallurgical Laboratory, where I spent some time. So yeah, so but here, Broken Hill, one of our solar farm, 53 megawatt. Actually, that was 2017. It was commissioned, and you can see that although since then a lot of developments happening in the renewable energy technologies, particularly wind. Our wind has got good resources, and you can see the bottom photo is the I'm not driving that one. That's a kind of demo car in Australia. There are not many, probably a dozen car at the moment. Hydrogen fuel cell vehicle. So essentially zero CO2 emission, as you can see. And because the hydrogen, when you use in a car, in a fuel cell, then you will only emit water. So in Australia, a lot of things happening around renewable energy, around this kind of technology, because reducing emission, and particularly carbon emission, is one of the highest target for all governments. Everywhere there are efforts going on to reduce that. And then all these technologies, particularly wind, you know that neodymium is used in a fuel cell. There are lots of rare earth elements, is the forefront of all these technologies. So I think the rare earth future is pretty bright and bull, I would say, but at the same time, where are the resources? And obviously, we need to think about in mining industry about the secondary resources, because obviously we know that mining industries, we are dealing with finite resources. So just I think a bit of outline. I'm going to talk about myself a bit of more, and then REE, rare earth elements. That's our main topic. As I said, I think to understand obviously secondary resources, we need to know a little bit of primary resources. And I probably attended one of the presentation arranged by you in the past, but I will complement some of the activities here. And again, I'm not going into detail of those. I will give some overview of that. But what are the challenges, and with some concluding remarks. And you can see some of the photographs, the wind power, battery fuel cell car, and the renewable energy technologies, all using rare earth. So actually, I originally come from Bangladesh, although I left almost 25 years ago. So half of my life I spent outside Bangladesh, and living in after my master's from the University of Wales, I came to Sydney, did my PhD. And then moved to New Zealand Forest Research Institute, one of the Crown Research Institute or government research facility. Last 16 years ago, I moved to Melbourne, and since then, I'm working at CSIRO. Probably you know your Indian CSIR. We have our sort of counterpart institution over there. So I know CSIR has got many labs around India. Similarly, CSIRO in Australia, we have got 60 locations in all these capital cities and various other local labs doing research. Mining minerals is one of the key one. I was a team leader in minerals research for a while, and led a lot of projects, big projects also. And then now currently I'm moving into energy research because given that lot of movement in the renewable energy research. So I'm leading hydrogen energy research in Melbourne in CSRO lab. One of the best facilities around the world on hydrogen actually. So we're lucky to and privileged to have those facilities with us. I also teach at universities, mining engineers, Monash University. I teach mineral processing there, and a couple of other universities. I am a sort of guest lecturer for life cycle assessment, which is environmental evaluation of mining industry and renewable energy technologies. And also I'm a fellow of the Australasian Institute of Mining and Mineral and Metallurgy. You probably Australian Institute of Mining and Metallurgy, they call it, yeah, AusIMM. And also I work with other professional bodies. So I think that's enough, but just to give you a bit of context that, yeah, again, not far from, I don't know where you said, probably Nagpur, but I sort of grew up around very close to around the border area of Bangladesh, India, where Kolkata, not far from, actually, some of the relatives still live in Noida district of West Bengal. So, but as I said, travel to Bangladesh and India and that part of the world. When I go to sometimes lectures, I show this map and tell about, ask the students, what do you think about this map? And there's a lots of things, but I can tell you that it's a diversity and probably diversity in the chaos, because a lot of and peace, you can say, the harmony in chaos, essentially a lot of different nationalities, different languages, and even if you talk about the landscape, but it's still fascinating place. So I go to India, I said to my colleagues that to energize myself. Actually, my son says that if daddy is given choices of Delhi and Paris, he will go to Delhi. I said, yeah, for sure. So anyway, so a lot of international activities I'm involved with in terms of research, and that's what how I learn about some of the mining activities around the world. Chile, copper producer. Korea, actually, a lot of rare earth work we have done over the years with some of our Korean partner organization called KIGAM. You may heard of Korean Institute of Geoscience, Geological Science and Mineral Resources, kind of that, KIGAM. Obviously, IIT Dhanbad, as I said, we had MOU with IIT Dhanbad, ISM, actually in Indian School of Mines. And I work with Bangladesh government and obviously South Africa, all this mining industry, wherever that is strong, we have some connections. I think last time I visited in India as part of our ministerial delegation, our trade minister, former Australian government sort of selected me one of the delegates in that team. And part of that, we visited various parts of India, and there was Australia Business Week in Delhi. And I think that was the main reason I went. We had MOU with NTPC and a few other organizations around that time. So that I was introduced that what is my strength or area. If we say that the two areas, although it's a kind of hard to see from your end probably, but one is called techno-economic evaluation. Obviously, you in the mining industry are very familiar with. You have got a deposit. You need to know what is there after drilling and I guess resource assessment and assessing the grade and resource, and then do some test work. Establish the flow sheet, I guess the process routes, and then do some evaluation. And I do techno-economic evaluation of various small, large mining projects. And slowly, you're probably familiar with the term is called ESG, environment, social and governance. And most of the companies nowadays, at least they're trying to develop some reports and indicators and KPIs around that mark. So life cycle assessment is another technique, and which is kind of I'm practicing that or applying that in the mining industry for a while. And we have, you can say, calculated and reported the carbon footprint. I often familiarized or coined a term, not necessarily coined, I took a selected environmental impact. We call it ECWW. So E for energy, primary energy, C for carbon or carbon dioxide, essentially. ECW, one W is water, another W is waste. And what is the ECWW footprint? So for example, megajoule of energy respond, please? Seems like I've got maybe disconnected. Is it?
Yeah, we just lost you for a moment.
Yeah,
Continue.
now it is all right. I think you can change your slide.
Okay, so I think maybe hope internet will not fail us. So let's continue. So you can see that in the diagram life cycle assessment that what I call mine to metal. So essentially you have got a deposit and then obviously you, I hope it looks like I'm stuck with the slides. Can you hear me now, by the way? Am I still connected?
Yes, sir. We
Hello?
can hear you. You are right
Okay,
now
all
on
right.
Techno
Yes.
evolution slide.
Okay, so maybe connection will be hope will be okay. So I'm just which slide you are seeing now is that resources journal paper highlighted rare earth elements, overview of mining, mineralogy uses and sustainability and environmental impact. Can you see that?
Yeah.
Can you respond? Yeah, that's good. So that we published in 2014, and actually for this talk I was going to look at what's the, and looks like that is the top 10 cited second in the and actually first top paper is also one of our colleague here in Swinburne University, but the second paper is ours, and seems like it attracted a lot of citation, and all time looks like that time I started actually a little bit. I started with rare earth before then, but that was the first time we published one paper on the sort of primary and also sustainability, primary resources. Secondary resources we covered a bit because environmental impact. And when you talk about sustainability, you talk about recycling and things like that. And that's where we're going to talk about. I had a student, Jihan Weng. He's now working for Geoscience Australia, Dr. Weng. And we published together. We had a project on rare earth, essentially. So we probably, as part of this project, there are a few other papers you can Google probably. We looked at all the projects or resources around the world on rare earth. And rare earth dominated by China, but also outside China, there are a lot of resources. In USA, Mountain Pass, Bayanobo in China, which is essentially iron ore mine, but rare earth is the byproduct. And also in Australia, we have recently got into the production like Mount Weld. And so as part of this study, we looked at all the resources in the world. We compiled them with grade and a lot of secondary resources, and secondary resources can be even mine tailings. In Australia, we have a deposit called Olympic Dam in South Australia, which is the largest, world largest uranium deposit. It's a kind of multi-metal mine, so uranium, gold, copper, and silver. But our tailings from that mine is still just stored there, and it is rich in rare earth. If we talk about that, so that could constitute significant component of rare earth. And I'm not sure whether we should turn that as a secondary resource. Probably we should. But also there are a lot of other products, after use, potentially recyclable, say either electronic gadgets, e-waste, what we call electronic waste. We have done some work around that area. Probably I'll talk a little bit about that. So in terms of rare earth, where it is used, we know that all sorts of EV vehicles and wind turbines and obviously gadgets, any screens you talk about, and obviously homes. So it's a demand for electric vehicles has accelerated. Obviously, we know that one. International Energy Agency reports 41% growth in electric vehicle registrations in 22 versus 2019. So obviously, it's growing up. Wind capacity, that's I think one of the solar has gone significantly, but in the renewable energy, I think wind is the largest contributor in terms of proportionate contribution. So they are saying that 90% increase in 2020 to 114 gigawatt globally, and 2021 additions expected to be another 880 gigawatt. Consumer electronics market expected to grow to 17.7 billion. Actually, that was one of the presentation. Linus, which is the company I'm talking about, Mount Weld mine in Australia, they just gave very recently in their diggers and dealers conference presentation. Global smart homes market expected to surpass 289 billion by 2030. And also again, various sensors and things like that. Obviously, that's why the market looks pretty strong for rare earths. As part of Dr. Wang's PhD, as I mentioned before, we looked at various resources and we grouped them. And you know that resource is a prospect and that becomes a project. It's not easily. So a lot of the factors, where the resource is, what's the grade, how easy to recover, environmental aspects, governments, stability, all sorts of things. Yeah, there are a lot of rare earths probably in Afghanistan, but there are issues, that sort of stability and how we would access those resources. So if we actually there is significant rare earth around the world, 83 billion ton according to our that estimate, and there are 268 deposits. However, there are confidence level depending on how they're reported, how many drillings, what sort of sampling techniques have been used, and so on and so forth. And we can express in terms of total rare earth plus indium. We know that 17 elements kind of lanthanide series plus in scandium and yttrium. And then the grade, you can say that can vary. So on an average 0.74% of mixed kind of rare earth grade. So if you are interested, you just Google that paper and you will find quite a lot of information. Still just checking, everyone can hear me okay? Hello?
Yes, sir. We can hear you.
Yes.
All good, thanks. So, but as I said, I mean, deposits not equal to mines and mineral resources not equal to production capacity. So there are a lot of factors, although there are a lot of resources, but we need to make sure how to extract that. And that's again my specialty. And probably when we talk about mining industry, we say mining, maybe mineral processing. But at the end of the day, people are familiar with the product, that whether it is a car, and actually that my old car, typical locally immigrant friendly or popular in the immigrant start a Camry, but essentially the Howrah breeze, you can see that on all these products, what I'm going to mention, that's what people care about, but where they come from doesn't matter. That's the screen of the TV. You can see that one coming from, there's a ring, definitely not mine, but maybe picked from the internet. But essentially, Australia produces a lot of gold, but again, some of our mines can be multi-metal, including rare earth. And obviously, if you define those elements, light rare earths, we can say heavy rare earths, and you can see the heavy gadolinium, tritium, and also yttrium, probably in that category, rest of them light. Sometimes people say another medium heavy, but so this is one of the Linus flow sheet. Why I'm talking about primary resources, probably that will give you a bit of context. Why should you look for secondary resources? Because primary resources or rare earth production primary resources are not easy, really. So you have got, say, ore, you crush it, you grind it, float it, and that's a typical sort of Linus flow sheet, I would say, in Mount Weld. We have got filter press, and you get a concentrate. So 4 ton to 1 ton concentrate, 40% rare earth oxide. And then concentrate to sulfuric acid mixture. You add acid and fuel in rotary kiln, you digest, water leach, filter it, and you produce sulfate, and obviously then filter it, and then you purify it in rare earth separation, precipitation, product finishing, and then you can get a probably separated rare earth products. So at the end of the day, mining happening in Australia, we make concentrate, and that concentrate goes to Malaysia in Gebeng, I think one of the facility called LAM, Linus Advanced Processing Facility. And there they do that one and they send around the customer. So I was mentioning in the beginning that China is dominating the rare earth market, as you know, and mainly Japanese and Koreans, they're the main user. US, a lot of activities. Mountain Pass was the first mine. US had a big proportion, Russia, US, I think, and slowly it was taken over by China. And then, there were a lot of, I guess, debates and issues when the WTO had embargo on the and Chinese restricted rare earth. That was a bit of international relationship issues. So slowly, because rare earth also strategic metals, used in some of the defense applications. So USA also looked at where are the outside China we can look at, and Australia has got some resources, but our Mount Weld, which is in Western Australia near Kalgoorlie, which is our gold province, and you can see that they started producing rare earth, and now, in fact, after China, this is one of the production in the mix. If you look at the pie chart, if we look at I think that's again a standard, sort of not too much to know. Really, it's everybody knows the various rare earth, the element, the atomic number, the element name, light or heavy, and there is this, although we say rare, actually some of the other metals are rarer, rarest than compared to rare earths, but it's still quite very small quantity, as you can see. But obviously, if you look at the uses, all these products we cannot live without current civilization, like say mobile phones or screens or you name it, magnets, wind turbines. So that's all sorts of applications. So I'm sort of moving into a little bit into deep into that. Obviously, monazite is one of the source, hard rock or monazite for rare earths. I mean, and we know that India has got a lot of placer deposit. Any country, Australia is one of the largest producer of mineral sands. But again, monazite at the moment are kind of waste. We don't do anything with monazite because of the radioactivity, but that is stored somewhere. So hopefully we'll get rare earth from that. But essentially, you can we have looked at some of the flow sheets like this, so you can see quite a detailed flow sheet and look at their cost. What is the capex to set up a plant like this? What would be the operating cost for, say, basket product or mixed rare earth? And then if you do separated rare earth, but you can see huge amount of, so you need to have tailings and quite a bit of complex flow sheet, a lot of various, gravity separation, your shaking tables or magnetic separation, things like that. But quite all sorts of equipment used in mineral processing, used in rare earth processing essentially. And then once you have got obviously a mixed rare earth concentrate, that one route, and then individual rare earth flakes from mixed concentrate, that's again, you can see we are getting sort of acid resolution and light, two streams, light and heavy. And the light, you can have neodymium, and then rest of them, say cerium, lanthanum, and final neodymium as a product of praseodymium, obviously lutetium, and ytterbium, thulium, and holmium, and erbium. All these individual, and mostly, I think, for example, lanthanum, praseodymium, some of them are obviously neodymium is magnet used. Cerium is used extensively. So, and some of them are lesser used, but maybe high value rare earth products. So now if you look at some of the cycles, I guess, I mean, that obviously we get from rare earth primary ore source, you get rare earth metal alloys, sometimes phosphor, you make goods containing rare earth, end of life, the goods has to be dismantled or pre-treated, and then you recycle containing rare earth, and then you can recover rare earths, and it can go to the leachate. There are lots of processing routes people are working on in the various parts of the world, in Japan, in China, in Korea, and I'm sure in India a lot of activity is happening, but I'm not sure exactly who is actively working on that space now. But at the end of the day, it's looked at seriously, because that if you look at we have done one studies on that, for example, all these electronic gadgets and how much they're produced in a particular country or imported in a particular country, then you can predict that when that will be redundant or when will be that will be end of life, what sort of accumulation rate potentially, and what would be your total resources, because you know that one it's not the same as the resources in the deposit. The grade would be higher, but often it is mixed with other metals. It's a quite complex processing, so that's why WE, I think, waste electronic and electrical equipments kind of thing. So they have got obviously rare earth and other precious metals, and at the end of the day, precious metals or content and recovery of precious metals from electronic waste will make your flow sheet more attractive. And obviously rare earth, you can have mixed alloy, but at the end of the day, separated product would be most, I would say, suitable. Another source in the secondary rare earth product, actually, we just submitted a book chapter on the rare earth from secondary resources. Hopefully that will be published in the near future, and happy to share anyone wants that. And if you look at these, some of the papers or sources we looked at, coal fly ash from Polish and UK power plants in ppm, and USA, because you have got different varieties of coal, is a natural material, we know it's coming from obviously fossil fuel, and resources depends on that particular location, geology, and so forth. So that some of them, that's why it is the varying and depending on which ore source, which coal source you are using. So you can see cerium, lanthanum, they've got quite significant quantities in the fly ash, and particularly in USA fly ashes, particularly the light rare earths are more common. So that's again need to be looked at, potentially separating that, collecting that. It's not easy. And then there are some of the flow sheets, like probably you can think of, say, obviously we know that coal is used in the boiler, and then bottom ash and fly ash, two types of ash we know in the coal-fired power plant. And particularly in India, I know there are large thermal fleet, thermal power plant fleet, and Indian coal has got high ash, as you know. So potentially that could be looked at in terms of source of rare earth elements. So often what we do, alkali leaching, then you filter it, you wash it, and obviously then acid leach, and then purify, and then you can make rare earth products. But one of the thing is that because the low grade is still, your residue or waste footprint would be pretty high. I don't know how I'm going with time, so hopefully another. So I don't want to talk a lot. Maybe we can have some time for discussion. So one of the, I think this book, probably those who are working in rare earth, Krishnamurti and Gupta, is one of the classic textbook. So you have got nitrate form in lanthanum, praseodymium, neodymium, and samarium. You can have some solvents and solvent extraction route, and then again, you can probably get neodymium and samarium products from this sort of processes. So another one is phosphor. As you know, phosphor used in the lamps and lights, rare earth containing phosphors, and then you can end of life can be recovered, and obviously leachate, and again, kind of, this is one of the flow sheets has been proposed to recover phosphor. I think majority of what our assessment or understanding says, that we know that renewable energy is improving pretty fast, and at the end of the day, renewable energy, particularly wind turbines, quite large amount of neodymium magnets used in the magnets. So how to recover that neodymium? And we know in electronic, in the computers even, we have got you know, that sound system everywhere there is a magnets, and then that neodymium is there. So how to recover that one? So here one of the, again, that process, that end of life magnets, you either wind turbines or electric vehicles, you separate that in a recycling plant, obviously disassembly, collection, disassembly, separation, and then once you have that resource or sort of feed in a form, you need to reduce into size, and then you can either leach it. I think potentially look like hydrometallurgy is the best route, or reasonable preferred route for rare earth recycling. I know in Japan, Hitachi, they have developed a process, at least couple of techniques they have, or routes they have proposed. Some other companies are working on. However, I have not seen really commercially a big plant as yet to be seen. I know some of the, I mean, in terms of recycling of metals, it's not dissimilar to rare earth, although rare earth quantity is small, and also there are a number of rare earth. That's why the problem or the issue comes and challenges come. But at the end of the day, I know in Belgium, Umicore, there are few facilities in Korea, like Sangil High-Tech. We have visited their plants a few times in Korea. So what they're doing, they are, for example, electric vehicle, end of life electric vehicle batteries, they're taking it and they are dismantling it, processing it, and using hydrometallurgy. Some of the people are using pyrometallurgy, like the Umicore example I have given in Belgium. So what they do, they use high temperature to separate slag and metals, and then metal alloys. Maybe slag can be crushed again, and then you can use that to recover your using some sort of leaching activity. So at the end of the day, I think you can have all sorts of resources, whether primary or secondary. But at the end of the day, I ask these questions to make a business case as we said, the mines not equal to deposits not equal to mines, or mines not equal to the project or profitable project. So to make that one, you need to do evaluation, techno-economic evaluation. And also nowadays, you know that Bayanovo, I was mentioning the Chinese, the main rare earth, Basnanite road they use, but again, that's iron ore, originally iron ore mine. However, or kind of product, another product, multi-product. But the main issue is that environmentally very, very crude way to process that one, and environmental impact of that rare earth would be very high. So nowadays people are talking about, obviously you need to have economically feasible, but what about the environmental performance? Because at the end of the day, we are trying to introduce all these new technologies, whether it is renewable technologies, renewable energy technologies, or other technologies that is supposed to reduce the CO2 footprint or reduce the environmental impact. So if that is not met, then obviously, and same sometimes recycling, the products are spread around the places. So main issue with the secondary product is that you need to collect them in a place, and they are spread in large geographical distances or spread around the areas. So I think the end of life, obviously we need to predict that. We need to know how much material is coming, because unless you have got a consistent and I would say confirmed inventory of material, you can't have a plant. So once we have that one, these sort of questions we need to ask that, I mean, when we do the techno-economic and LCA, what are the main objectives of this work? What is the boundary we talk about? You know that when I said ECWW, energy, carbon, and water and waste, that is within your boundary, but you are bringing a lot of products. So like you can see that any of these rare earth processing routes, you are taking a lot of acid digestion or alkali, and where they are made, they have used energy and water, carbon, waste, they have got their own footprint. So when we say ECWW footprint, it's within your boundary and also indirectly coming with your input. So that has to be added. So that will be the total life cycle based impact. And obviously then what life cycle indicators? So life cycle assessment, actually not only carbon footprints, but also there are lots of other indicators. For example, photochemical oxidation or ozone depletion potential, or eutrophication, that is kind of release of fertilizers in the that emitted in the water bodies, toxicity. There are lots of impacts. Obviously, global warming potential or CO2 footprint is one of the main ones, and most people are familiar with carbon footprints. That's why. Now, what are the input data? You can see that processing routes could be complex, whether it is primary or secondary. So we need to make sure that there is enough input data available. If not, we need to generate those. I hope you can still hear me. Okay, I'm connected still. All good. Just checking.
All good, sir.
Yes,
All,
yes, sir.
yes, all good.
So then, so I'm just so far, since I was mentioning about the environmental area, but at the end of the day, economics dictates above all everything. So what is the CapEx? What is the OpEx, capital expenditure for a particular project? What is the operating cost would be per ton of product? And obviously sensitivity of the rare earth price. It's quite volatile, as you saw that one in, I think, 2012, it went high and then dropped down, and rare earth, depending on the market, depending on the, the geopolitical issues, and that's the definition of critical minerals. We are involved with some of the activities. Australia, India, there are a lot of discussion going on to have concrete work around critical minerals and involving probably some of the other trading partners like Japan. So I think we are thinking around, for example, Australia has got a lot of resources. Obviously, we are a lucky country. In any mineral products, you name it, Australia would be one of the top or second or third, if not within top 5. So we have got a lot of resources, and now we can mine it, we can process it, make a concentrate, like say what we are doing now in rare earth. We're sending to Malaysia, maybe we can send to India, and then you can process there, you can have some products, and that can go to say high value, not necessarily high value, the final products like say batteries or wind turbines, or countries like Japan or Korea, and it's a nice sort of everybody wins there, and kind of nice sort of scheme, collaborative activities. So but at the moment we are seeing a lot of movement, a lot of discussion around Australia and India diplomatic relationship, even at the government levels, and we are part of that also. What is called critical energy metals, or critical metals essentially, and there are definitions. based on the rarity. Obviously, most of the rare earth would be under critical minerals. The applications, like even the defense application potentially, and also your obviously how much is their rarity. So and then political situation, stability, things like that, governance, all these mix, and then you define what are the critical metals. And critical metals in one place may not be globally. We have a bit of definition and criteria, but then country-wise, some are then critical, some of them are critical, some of them are not. But in Australia, we have got plenty of resources, as I've told you. So, and then obviously these sort of reports will be very useful for your technical marketing and your justifying the project essentially. I mean, you know, there are levels of work. It is pre-feasibility, high level kind of back of the envelope, to bankable feasibility, which is if you take that report to a bank, they should be able to give you the loan. That sort of faith and that sort of, I guess, the reliability or credibility should be there in terms of sampling, in terms of test work, in terms of the feasibility of that route to recover rare earth. So I think I'm towards the end. So essentially, I think I spoke quite a while that about sort of minerals, metals, and sustainability. This is one of Dr. John Rankin, one of the best metallurgists I have known in Australia. He was our chief scientist. At the moment, he's our honorary fellow. He published this book for a while, 2011, but it's not only rare earth, but all the major metals, minerals has been discussed here, kind of Bible in this area. I think in summary, if I say that obviously rare earth dominated currently by Chinese, but there are a lot of rare earth resources around, even the primary resources. But again, whether they are in tailings or low grade, that needs to be established, and to make into a project or commercially viable venture, that needs some evaluation work, and that techno-economic and life cycle assessment can help, obviously internationally recognized and good tools. But also another thing is that a lot of secondary resources are coming, and you say that one electronic waste, or another thing is that our solar panels, our renewable technologies, the wind turbines, we know their lifetime would be probably 20-30 years, or even say solar panel would be around 20 years, 25 years. They're talking about lot of these materials would be available. So at the moment, maybe it seems like the volume is not that much, but say next 10 years time, we need to think about rare earth extraction from secondary resources. And as I said, there's probably not a lot of establishment commercially big doing it, but primary resource extraction and secondary resource extraction should not be that difference. But obviously there are a lot of challenges, and challenges are because there are so many elements in one place. There are little differences between the elements, and getting them either pyrometallurgically or hydrometallurgically all in combination would be obviously challenging, and at the end of the day, economics and environmental performance of the project will dictate. So I would like to acknowledge various colleagues who I work with in my organization and outside, learn from them, my PhD students and colleagues, obviously. So that's what I wanted to say, and thank you for your time, and I'm happy to entertain questions. So here I've not covered a lot of detail, but just wanted to give you flavor what is happening around in Australia and elsewhere. So, and then you are feel free to Google us, and there are a lot of papers we have published, and can use as references. At the end of the day, the world we need to look after in terms of sustainability. Mining, we know it's a finite resources we are dealing with. There is a one earth, and we need to care and share. And with that note, thank you again.
Thank you very much, sir. The presentation was quite exhaustive. So I'm sure many people will be having a lot of queries. We already have Mr. Nagesh. He has a question for you. Others, if anybody, they can write in the chat box if they have any questions, and if anyone has any more questions, they can raise their hand. So yeah. Yeah, Mr. Nagesh, please.
Yeah. Good morning, all of you.
Good morning.
Sir, I have a question. Do you have any idea about extraction of minerals like copper and other precious metal? And we are recently thinking about rare minerals from our copper tailing.
So copper tailings, I think that has to be looked at in terms of the content, copper and rare earth. Obviously, the primary resources, when we mine it, we take as much as recovery possible, and recovery should be high enough, so less metal reports to tailing, but still we cannot avoid that. And nowadays, in Australia, we had a lot of gold, and actually gold tailings becoming then a resource for gold. So could be possible. I think it should be case by case, but what I found that from secondary resources, my experience is that unless you have got multiple products, so if you look at copper tailings, maybe you need to look at some other metals, because the copper grade would be relatively low, obviously. So if you can get some other product which is reported in the tailings and you can recover that one at the same time, that will justify or make the process more attractive. But again, what process is required, you need to look at various test work. And yeah, at the moment in Australia, we have got so much primary resources. We have not really concentrated too much on the secondary resources in terms of, I mean, we have some development work going on, R&D work, but really not seriously we have done any commercial plant, any such like, say, except gold. And then that's another important point. If you can get some precious metal in those tailings, then that will determine the flow sheet, as I was mentioning before, that attractiveness of the economics of the flow sheet. I'm not sure if that question's answer. So yeah, it has to be tested really, that by test work, and you need to follow and establish the flow sheet.
Can we thinking about this matter over this meeting? By
sure.
mail?
You can, yeah, you can communicate me. I have, you can get the presentation from the organizer and just yeah, contact me and we can go from there. As you know, this is much bigger kind of discussion requires.
Okay, I will contact you.
Yeah, you can definitely be in touch with Dr. Nawashad. You can be in touch with this.
Any other question?
Yeah, we have one more person asking. Before that, there's a question in the chat box from Ajay Pabi. So he wanted to know what should be the cutoff RE in fly ash for it to be economically extractable.
That's another very good point and good question. Anywhere, if you say we know that cutoff grade in our primary resources, we can establish easily. But with the fly ash and rare earth extraction from fly ash is really, I would say, complicated process compared to the primary resources. And fly ash is, you know, that very fine. Also, there are a lot of issues in terms of filtration and then some other chemical leaching and things like that. So, I mean, again, you need to do some techno-economic evaluation. What is there, what the process looks like, what's the consumption of acid, and finally, that will, if you have good recovery, obviously the cutoff grade can be lower. But I think those amounts I've shown, I think that yet to be seen. I wanted to do that one. I wanted to show that what are the obviously primary resource compared to primary resource and the fly ash resource, what sort of differences. But generally these, I mean, if you talk about the electronic waste one, I can give you an example. So for example, all our mobile phones, end of life mobile phones, that we have done quite a bit of work around that. It has got mixed metals, including rare earths and gold particularly. And there are a lot of literature reporting, if you say 5,000 mobile phones make a ton of electronic waste, which has reported grade, actually we have done some tests ourselves too, anywhere between say 10 gram per ton to up to probably 3,000 gram per ton, depending on resources and time and brand of phones and when it was collected, all sorts of things are there. But we found, say, even say 10 gram, if you say, or the lowest one. So if you talk about the gold grade around the world, and even copper grade also, I can tell because we look at those, this is kind of ones are bread and butter, how much resources are there, what is the grade. So gold is typically nowadays is mined at probably 1 to 2 gram per ton. So if you get that sort of grade, say 2, 3, or 10 gram per ton, people will be really jumping up and down. We have got a really good resource. I mean, I'm not a geologist, but you can see that one, that any electronic waste, because you already, I mean, in mining business, what we are doing, we know that whether it is rare metals or any other things, very low grade in the actual natural source. So what we are doing, the whole mining business is concentrating, isn't it? We mine it, we concentrate it, say even copper, say from 1%, typically now probably around the world, that's the grade plus minus. But that's, you know, that grade is going down, declining, ore grade is declining. That's one of the challenges, because we are mining the good quality resources all the time. So now what we are doing from 1% to 23 or 25 plus 25 to 30%, which is the intermediate product, copper concentrate. And then we are putting in a smelter, we are making that 99.999 or 59s purity, any of the metals, because that's required, for example, conductivity, for which is copper is used for electrical industry, electricity distribution, or even all these electronic gadgets. So, and then once we have multiple products, we are distributing the elements again, even rare earths. So we are extracting, refining, concentrating, enriching, and then distributing back again. But how to get that back? That's the trick. And then obviously cut-off grade. That's, I think the secondary resource has to be treated like primary resource similarly, and then you need to do evaluation, what resources, what, how many elements are there, what is the grade of those elements, and what is the best recovery route after test work, and then do some evaluation, and whether the product per ton of dollar per or rupee per ton of product makes sense with the cut-off grade, and that's you establish that cut-off grade. So it's hard to say exactly what the cut-off grade is, but that varies between project to project. I'm sure, I don't know, I think whether that answers exactly the question, but sort of broadly, roughly what I can comment. Any other question?
Yeah, so we also have Mr. Prashant Modi. I think he has a question. Mr. Prashant, you may please ask the question.
Good morning, sir. I am a research scholar from IIT BHU. Sir, I have a question regarding REE, that is the recovery of REE from coal and byproducts can be called as beneficiation in coal.
That's actually some of the tricks are happening. That's a good question actually, because when you process it, I mean, process the material, I mean, still we are, I mean, it depends. I mean, like I was giving the example of Australian Olympic Dam. It's the largest uranium deposit, obviously. It's a big, huge deposit, Australian gold, copper, uranium, and silver, 4 metals we get. So any mining companies we have worked with, say BHP, Rio, all Australian giants, mid-level and juniors also. So whoever working on particular mine, that's their focus, that's their concern. They don't care what is reported in the rare earth. As I said, Olympic Dam tailings, huge amount of tailings is already stockpiled. And that would be if we do proper not only study, I mean, that's already there. We know that one. If we calculate that one, it will skew the whole global rare earth resources, because the tailings will cover probably 60% of global rare earth potentially. So now we are not. So now we are going back. Okay, so these resources are there. Where it's reporting to the tailing. Why not we take that during the process when we send to the mill, so that we can handle that material? But again, those companies might say, oh, this is not our business. Our core business is say gold mining or uranium mining or silver mining or copper mining, not necessarily rare earth. But given the market, as we've shown you, that renewable energy technologies, sensor technologies, anything you name it, the market looks like pretty strong in the future. So now we need to look at the upstream or middle, say mineral processing. When we make intermediate product, how can we check that one? So whether coal processing, during coal processing, obviously we know that one, it is reporting to the tailings. Potentially we can take some. That's a good point, really.
So we have one more person has raised a hand. I don't have his name live, got the ID. So can you please ask the question?
Go ahead. Thanks.
Yeah, me, Dr. Sharma. Hello.
Yes. Yeah.
I'm
Yes,
basically petromineralogist, geologist. I am having a question. I have been invited through Dr. Dhruv Nath, and I have joined you. It's nice, but I could not join in time. Sorry for that. And first, I want definitely a copy of your presentation, which is nice, whichever whatever the part I have listened is very good and very informative. My basic question is that is REE always a byproduct of a major concentrates, or they are being concentrated by REE minerals like lithium bearing minerals like lepidocrosite and spodumene or something other? Is it always value added products or a direct mineral which is being beneficiated as a concentrate?
So
RE, RE concentrate, yeah, please.
Thanks. So if you look at in Australia, so those RE can come from, as we know, that one of the hard rock deposits, or also beach sands or mineral sand, essentially placer deposit, monazite. So in Australia, as I was saying, that we had, I think we are one of the at least 1/3 of global mineral sand market we export. South Africa, Australia, I think India has got fair share of monazite for fair share of mineral sand industry. But in Australia, still now, monazite is treated as tailing, and we dump them because of the radioactivity, as I said. But if you have the processing one, we can monazite phosphate essentially. That's, you know, that rare earth minerals are there, or like say kind of in China, bastanite, or I think that's this is fluoroapatite probably. Those are the some of the. I'm not a mineralogist, but essentially the rare earth can be come from both sources. But at the end of the day, I think a lot of monazite resources, I mean, as I said, that Dr. Wang, who compiled the global rare earth resources, I think that was one of the largest comprehensive compilation we have reported and published. There are a lot of other people have done it. I mean, USGS and British Geological Survey. I'm sure Indians also, Indian Geological, if you look at some of the resources they're reporting. But if you look at that, many of the people, and monazite is not really treated as that way rare earth in terms of resource quantification. That potentially could be one, but majority of the cases, if you look at the Chinese one, that's the bastanite, and in Australian Mount Weld is also hard rock ore, but that could be another resource. So to answer directly your question, that yeah, if I say that one, it's a kind of, it should be byproduct for majority of the mines. That could be good additional revenue with a certain and additional of activities and cost and processing, things like that. My experience is more in the processing, modeling, simulation of the processing, and optimization of the processing. But I would say that processing can be clever enough to extract some of the minerals at the same time when you do your major mineral mining.
Thank you.
Thank you, sir. Dr. Sharma, I would also like to add, in our first Partner in Progress meeting, so we had a session by Dr. V. Balram, wherein he had explained in detail about the occurrence, mineralization, and geological environment, which is also available on our page. So maybe if you can have a look at that also, you will get much more idea than whatever Nawashad said. So it will be just add on to that. Yeah, thank you. Thanks for your question. So,
yeah, I have shown some of the detailed flow sheet of monazite. Those particular research scholar or students, you can probably look at, and also develop simulation models for Indian resources, and it would be good to see that one. And I'm happy to assist anyone interested in that sort of area.
Yeah. Thanks, sir. Dr. Balram, sir, anything to add from your side before we close in for today? So you're on mute, sir.
Oh, sorry. It's a wonderful lecture by Dr. Nawashad. I think he has given, I mean, a different perspective to what I gave last month, and more of application in nature, and with a lot of experience he has. I think he gave a wonderful information to all the people, and I congratulate him for a wonderful lecture. I think that's it. It's a. I think he almost started where I stopped.
Exactly.
Then continued. It's really wonderful to see.
Yeah, that's why I said, like, if we can go to the past presentation which was given by you, we can understand the occurrence, origin, geological environment, everything. And then today we spoke about the commercial part, and if at all anybody wants to start a business, what are all the pointers, what all things he has to keep in mind. That all was covered today by Nawashad, sir. So, so just before we close this, I would just request Drew to just show the next partner in progress meeting that we would be having and who would be the speaker for everyone who's present over here. Just in a minute.
Thank you very much for giving me the opportunity and speak to you. And yeah, I know India has got massive amount of mobile phones. I don't know, 130 million, what's that, 130 million people, maybe 30 million mobile phones or more you are discarding every 2 year, 1 year. So it could be huge resource for gold and other metals, and also including rare earth. And thanks once again for staying with me.
Yeah, Drew. Drew, can you just, yeah. So we'll be having next webinar would be on towards automating the 3D modeling of regional geology. So we have Professor Mark Jessel, so he will be giving the webinar. So it's scheduled on 25th September. So same time, so we would request everyone again to register, and it would be similar to something like this. So hereby I take this opportunity to thank Nawashad sir for spending his valuable time and enlightening us, enriching us with his vast knowledge. And we are very happy to be part of this presentation, and we hope in future also, like if we come across any queries, any difficulties, we will reach out to him. And also, Dr. Balram sir, thanks for being part of this presentation. So it was really wonderful. So I would also like to thank everyone for joining in. So that's all for today. So thanks everyone.
Thank you and good evening from.
Thank you. Sorry, I lost my connection a little bit. Thank you, sir.